All right, so this won't take very long. I'm going to actually show you how you're factually incorrect with your ideology about how sundials work on a flat Earth. So you're using what's called an equatorial sundial, but what you're not doing is angling the equatorial sundial correctly. So I'm going to replicate your experiment, and I'm going to show you how you're actually not. It actually does not work on a flat Earth, and we're doing it from these three positions, which are on the same longitude. So we're going to show how that doesn't work. And this is a different location, and this is a different location here. So we can see that, there's the shadow there, and there's a shadow there at that time, and here's the shadow on these three right there. All right, so what you're supposed to do, and what you did not do in your experiment, is show the sun moving at 15 degrees per hour. So each longitude line here is 15 degrees. So when I move the sun from here to here, that's 15 degrees. Okay, so that's going to be 15 degrees or 1 hour time. So when I move the sun from here to here, that equatorial sundial, which is not aligned correctly, is not going to work. Okay, so we're going to start out at number 259 down here, and we're going to move that 15 degrees over. So let's just see how that works. So 259, we're going to switch from 259, we're going to have 15, so that's now going to be 274. Now, right off the bat, we've got problems. One 15-degree rotation is 1 hour. So this has jumped to 2 hours. Boom, boom. Okay? This has jumped to just under 2 hours. And this has jumped to 1 hour and 45 minutes. So the whole time zone deal just got blown out of the water right there. Now, here we'll have to go and look at this. So let's go back to 259. So we're at this dial right here. Okay, so 15 degrees per hour is all we're worried about. So 259 from here, we're going to change that back to 274. It jumped not 1, but 2 hours ahead at 15 degrees. Okay, again, here's the sun. It went from here to here, 15 degrees of longitudinal position. Okay, so let's go to here. Let's jump back to 259. Okay, so we can see where the sundial is right there on that marker. So let's jump from 259 to 274. That jumped almost 1 hour and a half difference from this location. So now here's the issue. So here's another issue, I would say. This is on the southern tropic, December 21st. This would be December 21st. Now, what the problem is, on the flat Earth model, you have to actually know the elevation of the sun, how high it is in the sky. You have to know that on December 21st, and you have to know where it's at on the flat Earth model. And that's two things that flat earthers can't come to agreement with. What is actually the height of the sun on December 21st? Now, it appears to be over the southern tropics, so that's where I put it on December 21st. But I can't determine its height because no flat earther knows how high it is. So even at its core, you cannot ever make a sundial of any type work on a flat Earth until you figure out how high the sun is off of the flat Earth and what latitude position it is at any given point in time. So that is ultimately the problem with this when trying to make it work. Again, just shining a flashlight in a circle over a flat disk does not prove anything other than you know how to move the flashlight around. But again, this right here, it's all about shadows. It's all about angles. So 259 to 274, just moving at 15 degrees on the same longitude line, totally blows us out of the water. Okay, so to recap, we can't make a sundial of any capacity work on a flat Earth, not the horizontal sundials or the equatorial sundials or what you want to call the stick in the ground and with the light going around it. Because if you actually did the experiment correctly and did the movement of the sun every 15 degrees on the Gleason map or the azimuth projection, whichever map you want to do, the angles are not going to be correct. They are not going to line up. They are never going to match observed reality. So that is the ultimate problem. Just taking a flashlight and sticking a bunch of sticks in the ground and doing this doesn't prove anything, as I've demonstrated. So you're going to have to know what the elevation of the sun is on the flat earth model. You're going to have to know the latitude position of where the sun is over on a flat earth model to even begin to try to figure out how to make a sundial work on a flat earth. So at the end of the day, you don't know what you're talking about, respectfully. Other than that, if you guys have any questions or answers, questions or comments, let me know. I don't expect this individual to even respond to this comment or respond to this video. They haven't responded to the last two. So that's why I'm thinking the way I am. But who knows? It may happen. It may not happen. When I go this in depth with a flat earther, 9 times out of 10, they just go silent. You guys take care. Have a great day.